So we'll start with few questions on limits first. So this is a question. It says if alpha comma beta are the distinct roots of x square plus bx plus c equal to 0, then limit x approaching beta e to the power 2 x square plus bx plus c minus 1 minus 2x square plus bx plus c upon x minus beta whole square is equal to. Options are also given to us. Options are b square plus 4c. Another option is 2b square plus 4c. Third option is 2b square minus 4c. And then we have last option as b square minus 4c. So if you take x approaching beta, then in that case, this denominator will become 0. If x is approaching beta, denominator will approach 0. And the numerator basically will be, since beta is a root, so e to the power 0 will be 1. 1 minus 1 will be 0. And minus 2 into 0 will be 0. So what we observe here is, observation is that if you approach x as beta, then the numerator will be 1 minus 1 minus 0 by 0. That is actually 0 by 0 form. So now what we have to do is to do something so that its value can be found out. So first give it a try and keep in mind that beta and alpha, these are the two roots which will help you in calculation. So first give it a try. I'm giving you a few moments for that. Then we'll discuss. I will give you a hint also that if suppose x square plus bx plus c equal to 0 are having roots alpha beta. So you can say that x square plus bx plus c can be written as x minus alpha into x minus beta. So it is a very important hint because you have the roots, and from that you will get the factors x minus alpha, x minus beta. So x square plus bx plus c is equal to x minus alpha into x minus beta. This you can do and then think what should be done. So how can you express this question now? You can express it as limit x approaching beta. So the same question can be expressed like now. Limit x approaching beta. And then we have e to the power 2 x square plus bx plus c. So e to the power 2 x minus alpha into x minus beta. This is how we can write it. And then we have minus 1 minus 2 x minus alpha into x minus beta upon x minus beta whole square. That we don't have to disturb. That will remain as it is. So this is what we are getting. Now, if you can do two different approach here. One approach is the expansion of e to the power x. So e to the power x expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on till infinity. So if you consider that expansion, so this particular term, it is e to the power 2x minus alpha x minus beta. So how can this be written? Like is limit x approaching beta, and this will be e to the power 2x minus alpha x minus beta can be written as 1 plus 2x minus alpha x minus beta plus x square by 2 factorial. So x square will become 4 x minus alpha square x minus beta square by 2 factorial plus x cube by 3 factorial, that will become 8 x minus alpha cube into x minus beta cube by 3 factorial. And then we have my dot dot so on. Then this completes. Then minus 1 minus 2 x minus alpha x minus beta. So after writing this divided by x minus beta whole square. So this is how we can write it. Now, this is just the expansion of e to the power x. Okay, this expansion here. So in case of x, we have 2x minus alpha x minus beta. So that is what we have done there. Now, if we cancel the terms, so we can see that 1 will get cancelled with this minus 1. And 2x minus alpha x minus beta will get cancelled with minus 2x minus alpha x minus beta. So first write till here. Okay. So I hope you have noted it down. So if you proceed further here, what will happen? This is limit x approaching beta. And this is 4x minus alpha whole square x minus beta whole square by 2 factorial. And this x minus beta whole square, let us divide it with it. So what it will become? X minus alpha whole square by 2. 2 factorial is 2. And x minus beta whole square will get cancelled. Plus, then we have this 8 by 3 factorial, which will become 8 by 6, that is 4 by 3. And x minus alpha whole cube. And x minus beta will remain. And so on. So the further terms will have higher power of x minus beta whole square. It will be then x minus beta whole cube. It will be like this. We will get these terms. So if you put x as beta here, so what will happen? It will become 4 by 2 beta minus alpha whole square. And these all terms which will come after that will become 0 because beta minus beta will be 0. So either beta minus beta or beta minus beta whole square or all those terms will be 0. So you get 2 into beta minus alpha whole square. So this is the answer, but answer is not written in terms of beta and alpha. It is given in terms of B and C. So with that also we will do. First write till here. Okay, Levin is saying it is option C. So we have 2 into beta minus alpha whole square. And alpha beta are the roots of x square. Yeah. 1 second. Okay. So x square plus bx plus c is having roots alpha beta. So what will be beta minus alpha? So this implies that beta minus alpha is root d by a. A is 1, that is the coefficient of x square. And root d will be root over b square minus 4c. So this is how we write beta minus alpha. So beta minus alpha whole square would be b square minus 4c. So we can say that our answer is 2 into beta minus alpha whole square, that is b square minus 4c. This will be our answer. So if we see the option 2b square minus 4c, of course option C is the correct option. So let us come to the next question. It says limit x approaching to sigma n equal to 1 to 9 x upon n into n plus 1 x square plus 2 into 2n plus 1 into x plus 4 is equal to, options are given, 9 by 44 and 5 by 24 and 1 by 5 and 7 by 36. So here little bit of the concept of sequence and series will also be used. The concept of limit is very simple here. It is not like that it is any indeterminate form. It is a determinate form. So here students may unnecessarily get confused by the concept of limit. But here simple substitution will be done. And what we will get is that if we have x approaching 2, let us call this sum as S. So we can say, let us put x is equal to 2. Because here putting x is equal to 2 is not making it indeterminate form. So we will put x is equal to 2 here. And we will get this x2, here also 2 square, here also 2, like this. So this would be sigma n equal to 1 to 9, 2 upon, and if you simplify this, you will get 4n square and 4n plus 8n it will be. So 12n. And then we will have 4 plus 4, 8. So this would be equal to n equal to 1 to 9, 1 upon 2n square, 2 let us take common, plus this will become 3n, and this will become 2. You can write it like this. Now from here, you have to think about sequence and series. And I can give you hint also. In sequence and series, we have many methods. So the method which we will use here is the method of telescopic series. So first write till here and try with the help of telescopic series. Then we'll discuss. So after you do till here, what you need to do is this n square plus 3n plus 2, let us do middle term splitting. So what will happen? It will become factor n plus 2 into n plus 1. If you do the middle term splitting, you'll get these two factors. You can just multiply and check also. N square plus 3n plus 2. This is what you will get. Now this can be written as sigma n equal to 1 to 9. N plus 2 minus n plus 1. Because n plus 2 minus n plus 1 will give you 1. And 2 you can take outside. It is n plus 2 into n plus 1. Like this. So this is equal to n is equal to 1 to 9. 1 by 2. And n plus 2 by n plus 2 into n plus 1. So n plus 2 will cancel. Only n plus 1 will remain. And here n plus 1 will cancel and only n plus 2 will remain. Now see what answer you will get. Let's try telescopic series. So when you will start finding the value, term 1 will be n equal to 1 you will put. So it will be 1 by 2. 1 by 2 minus 1 by 3. Then term 2 will be 1 by 2. 1 by 3 minus 1 by 4. And so on till term 9. It will be 1 by 2. 1 by 10 minus 1 by 11. Now you add them up. So after you add them up, this will cancel, and like this. So it will be the sum 1 by 2, 1 by 2 minus 1 by 11. This will be the sum. So 11 minus 2 will be 9 and this will be 44. So 9 by 44, that is which option? Option A. Let us see a little different type of question now. LH rule. We all know L'Hopital rule. When it is applied, L'Hopital rule, it is applied when we have 0 by 0 form or infinity by infinity form. So in such cases, we differentiate numerator and we differentiate denominator. So this is L'Hopital rule. Now, if we see a question here, it says let f R to R be a function such that F2 is equal to 4 and F dash 2 is equal to 1. Then the value of limit x approaching to x square F2 minus 4fx upon x minus 2 is equal to, options are given 4, 8, 16, 12. So if you put x is equal to 2, it will become 4f2. This will also become 4f2. 4f2 minus 4f2, 0. The denominator will also 2 minus 2, 0. So it will be 0 by 0 form. So you have to see that it is actually becoming 0 by 0 form. So you can apply L'Hopital rule. You have to differentiate the numerator and the denominator, right? So what you will get when you differentiate the numerator and what you will get when you differentiate the denominator. This is the numerator. This is the denominator. This will be 2x f2, right? F2 is a constant, so it will be just multiplied. X square differentiation is 2x. And this will become minus 4 f dash x. Differentiation of fx is f dash x. Upon differentiation of x is 1 and differentiation of 2 is 0. So we can say that this is equal to required value is equal to this. Whereas limit x is approaching 2. What we get, limit x approaching 2 and 2f2x minus 4f dash x. This is what we are getting. Okay, someone has given the answer. Levin is saying it is option C. Okay, Levin, let us see. So if we calculate it further, so let us put x as 2. So this will be 2 into f2 is given as 4, right? In the question. So 2 into 4 and x is 2. Minus 4 into f dash x. And x we put 2. So what is f dash of 2? F dash of 2 is equal to, given in the question, it is equal to 1. So it is 1. So it will be 16 minus 4, it will be 12. So it is option D, 11. This is 2f2 into 2 minus 4f dash 2. Okay, let us come to some derivative of trigonometric functions. Limit, actually. I hope you have written it. So limit x approaching 0, sine square pi cos to the power 4x upon x to the power 4 is equal to, options are given, pi square, 2 pi square, 4 pi square, 4 pi. So which form is it? If you see, you put x equal to 0 here. So cos 0 will be 1, and that will become pi, 1 into pi, and sine pi will be 0. So it is actually 0 by 0 form. Now in that situation, how will you proceed? So here, let me give you a hint that you can use this expression sine theta is equal to sine pi minus theta. So if you use this one and do some manipulation, you can proceed. So what we will get if we apply this, we have sine square pi cos to the power 4x. Let us write as pi minus pi cos to the power 4x. Why we are doing this? That will be clear in few steps. So sine theta, we can write sine pi minus theta. So this is what we are doing here. Now this is sine square pi, you can take common, and 1 minus cos to the power 4x by x to the power 4. Now you can write it as sine square pi. 1 minus cos to the power 4x can be written as 1 minus cos square x into 1 plus cos square x upon x to the power 4. So this will be 1 minus cos to the power 4x. Now 1 minus cos square x can be written as sine square x. So sine square pi sine square x into 1 plus cos square x. We can write it like this by x to the power 4. First right till here. And also put the limit in each and every step because that is necessary. So this will be equal to limit x approaching 0 and sine square pi sine square x into 1 plus cos square x upon, now what I will do here, I will divide here by pi sine square x into 1 plus cos square x whole square, right? So this is one thing. Now we can't do it on our own. We have to multiply with this also. So pi square sine to the power 4x. This is sine square x whole square. So sine to the power 4x into 1 plus cos square x whole square upon this x to the power 4. So we can write it like this, right? Now we are almost reached to the answer. So first write this down and try to think what can be the further step. So after coming to this step, if you put x as 0, this term here, This will approach 0 because sine square 0 is 0. And this term here will also be 0. So it is form of sine theta by theta whole square, where theta is approaching 0. This is a square here. This is a square here. So it is sine theta by theta whole square, where theta is approaching 0. So this will be 1. Here sine x by x to the power 4, where x is approaching 0. This one, it will also be 1. So pi square into 1. And here cos of 0. So cos of 0 is 1. So 1 plus 1, 2. It will be 2 square. So what we finally get is 2 square pi square, which is 4 pi square. So Levin is saying option C. So option C, yeah, correct. It is 4 pi square. Let us come to the next one, limits of trigonometric functions. Next question. It says if alpha is equal to limit x approaching pi by 4 tan cube x minus tan x upon cos x plus pi by 4 and beta is equal to limit x approaching 0 cos x to the power cot x are the roots of the equation ax square plus bx minus 4 equal to 0, then the ordered pair AB is, options are given 1 comma minus 3, minus 1 comma 3, minus 1 comma minus 3, 1 comma 3. So you have to separately find alpha and beta. And then you have to use the fact that alpha, beta are the roots of this equation. And then what will be AB? So first task is to find alpha, the value of alpha, and the value of beta. If you see alpha, it is when you put x equal to pi by 4, the numerator will be 0. Tan pi by 4 is 1 and its cube is also 1 and tan pi by 4 is 1. So 1 minus 1 is 0 and in the denominator cos pi by 2 it will become cos pi by 2 is also 0. So it is 0 by 0 form. So you have to simplify by using some trigonometric identities or if you find some other way and then find the value of alpha. You can do one thing that when you will find alpha, you can write it as tan x common here and tan square x minus 1 upon cos x plus pi by 4 will be cos x into cos pi by 4 minus sin x into sin pi by 4 and cos pi by 4 is 1 by root 2, sin pi by 4 is also 1 by root 2. So this will become root 2 in the numerator. So root 2 limit x approaching pi by 4 and tan x into tan square x minus 1 by cos x minus sin x. First, this is the simplification. Then how you will proceed further. Just complete, try further. I'll be back in 2 minutes. So if we see here, this can be written as √2. So there are a number of ways, but the correct way, the shortest way, correct way are many. The shortest way basically is tan x into tan square x minus 1. And then we write it in the denominator cos x and divide by cos x. So cos x by cos x will be 1 and sin x by cos x will be tan x. So this is how we can write it. So this will be √2 limit x approaching pi by 4 tan x, and this tan square x minus 1 can be written as tan x minus 1 into tan x plus 1. And in the denominator, this is cos x, and 1 minus tan x can be written as minus of tan x minus 1. So what happens? This tan x minus 1 will cancel with this. Now it is easy to put x as pi by 4. So √2 is outside. Tan pi by 4 will be 1. Tan pi by 4 here will be 1 plus 1 like this. And here minus cos pi by 4 is minus 1 by √2. So what we get is √2 into √2, 2, 2 into 2, 4, minus 4. So this is the value of alpha. Alpha is coming out to be minus 4. So first write this down. Okay. Now we come to beta. So beta is cos x to the power cot x limit x approaching 0. So beta is cos x to the power cot x limit x approaching 0. Now which form is this? If you observe here, cos 0 is 1 and cot 0 is infinity. So it is 1 to the power infinity form. So this form is more associated with exponential function. So what we do in such form, we write it like this: limit x approaching 0, 1 plus cos x minus 1. We first write it like this. And this is cot x. Now this term is approaching 0. 1 plus cos 0 is 1, 1 minus 1, 0. And this is approaching infinity. And this whole is approaching 1. So we are talking about this. So in this situation, okay, Levin is saying option A. Okay, Levin, let us see. So in this situation, if we find the expression, so it would be e to the power, like if you remember, limit x approaching a, 1 plus fx to the power gx. It is something like this. And fx limit x approaching a fx is 0 and limit x approaching a gx is equal to infinity, then in that case, this is 1 plus 0 to the power infinity. So we write it as e to the power this will be gx, right? Okay. So it is e to the power. It was like this, no? 1 plus x to the power 1 by x. Limit x approaching 0 is equal to e. It was something like this. So if we write it, if you use this one, so what it will become e to the power uh, f. You can write it like this. I'm just deriving this expression because it is less used now. So that's why sometimes I forget. It is not difficult to find it out. So this is actually becoming equal to this one. Limit x approaching a 1 plus fx to the power 1 by fx into fx into gx, right? We write it like this. So fx will cancel and gx will remain. Now this 1 plus fx to the power 1 by fx is resembling this one. So we can say that this is equal to e to the power fx into gx, right? Where limit x is approaching a. So that means you can write this one also. That means we have this one here. E to the power fx into gx. So fx is cos x minus 1 into gx is cot x, limit x approaching 0. So you can write it in here. Now it is not so difficult to find this value of beta. Limit x approaching 0 and e to the power cos x minus 1. And this will be cos x by sin x, right? So it is now of the form 0 by 0. So we apply LH rule. And if you apply LH rule, it will be cos square x will be 2 cos x into minus sin x. And cos x is minus sin x. So plus sin x it will become upon sin x derivative will be cos x. So this is how we applied LH rule. Okay. But we did this one is e to the power cos square x minus cos x by sin x. So e to the power cos square x minus cos x by sin x. Then we differentiated it. Write it till here. Now we have to just put the value of x is equal to 0. So when you will put x is equal to 0, we are almost to the answer. So when you put x equal to 0, this will be e to the power 0. Because cos 0 will be 1 and sin 0 will be 0. This is 1 finally. So beta is equal to 1. This implies that beta is equal to 1. Now you can write it. I'm scrolling it down a little bit. If you are facing difficulty in understanding this formula which I have derived, you can ask me. Otherwise, you can directly also remember this. So now you have got the value of alpha and beta. Alpha is equal to -4 and beta is equal to 1. Now ax square plus bx minus 4 equal to 0 are having the roots ab. No, no. This is actually you have to find ab. And alpha beta are the roots. So ax square plus bx minus 4. Ax square plus bx minus 4 equal to 0 are having roots alpha minus 4 and beta 1. So sum of the roots -4 plus 1 is equal to minus b by a, which means minus b by a is equal to -3. And product of the roots -4 into 1 is equal to c by a, that is -4 by a. So a will come out to be 1. Now if a will come out to be 1, then here b will be equal to 3. So b is equal to 3 and a is equal to 1. So yes, D option is the correct option. You said C option, Levin, I think. Levin said A option, okay. So, but we have A1, B3, which means D option, no? Let us see a question on differentiability, right? Okay, Levin, you missed the negative sign. So if we have here the next question, the function f of x is equal to mod of x square minus 2x minus 3 into e to the power mod of 9x square minus 12x plus 4 is not differentiable at exactly option A 4 points, option B 3 points, option C 2 points, option D 1 point. Okay, so let us discuss this one. So if you observe this function f of x, x square minus 2x minus 3, you can do the middle term splitting. This is 3x whole square. This is 2 square, 4. And this is minus 2 into 3x into 2. So it is mod of x into x minus 3 plus x minus 3 e to the power mod of 3x minus 2 whole square. So it is x minus 3 into x plus 1 and mod of this into e to the power. This is a square and mod. So mod will not have any effect since it is a square. So we can simply write it out of mod. As the square is also positive, mod is also positive. So we can write it like this. So first you can write this function like this. So you can write it as f of x is equal to mod of x minus 3 into mod of x plus 1 into e to the power 3x minus 2 whole square. So mod function is not differentiable where it changes the definition. Okay. So what we can say here is that this mod of x minus 3 is not differentiable at x is equal to 3. All other will be differentiable at x equal to 3. And this one is not differentiable at x is equal to minus 1. All other are differentiable at x is equal to minus 1. This one is differentiable everywhere because there is no mod here. It is simply e to the power 3x minus 2 whole square. So if we observe that how many points are there where this function will not be differentiable. So it will not be differentiable at x is equal to 3 and minus 1. So there are 2 points. So option will be C. You can write it down.